Welcome back to Pinnacle, your ultimate source of networking expertise. In this lecture, we will dive into the world of routing protocol. We have to use dynamic routing to fulfill today's increased demand of internet. It gives updated information of network. Routing protocols have been created in response to demand of dynamic routing. Routing protocol is nothing but a combination of rules and procedures for routing. In this series, we will first understand interior and exterior routing protocol. Then we will study RIP, OSPF and BGP. If you didn't subscribe my channel, please subscribe for this informative video and don't forget to like, share and comment this video. Routing protocol can be either interior or exterior protocol. Intra-domain routing is handled by interior protocol and inter-domain routing handles by exterior protocol. RIP and OSPF is interior protocol and BGP is exterior protocol. OSPF and BGP are type of link state routing protocol and RIP is distance vector routing protocol. Internet is too much large in size. That's why one routing protocol cannot handle the task of updating the routing tables of all routers. For this reason, an internet is divided into autonomous system. An autonomous system is a group of networks and routers under the authority of a single administration. Example, our college network is autonomous system. Routing inside an autonomous system is referred to as intra-domain routing. From college server, you are sending mail outside organization. It's routing between autonomous system. Referred to as inter-domain routing. Means whenever you are sending mail outside organization is inter-domain, and when you are sending in your organization, then it is an intra-domain routing. To handle intra-domain routing, autonomous system can use one or more protocol. However, only one inter-domain routing protocol, BGP, is used by all the system. We will start with RIP protocol. RIP was originally designed by Xerox PARC Universal Protocol and was called GWINFO in the Xerox Network System Protocol Suite in 1981. RIP, which was defined in RFC 1058 in 1988, is known for being easy to configure and easy to use in small network. Understand the RIP protocol, our main focus is to know the structure of packet, how many fields it contains and how these fields determine the routing table. RIP means Routing Information Protocol and it is a type of distance vector protocol. First we will review distance vector routing algorithm. Distance vector routing algorithm is used in autonomous system with all routers and networks as a graph. A router is normally represented by node and a network by a link connecting two nodes. The graph theory used as algorithm called Bellman-Ford, also called Ford-Fulkerson, to find the shortest path between nodes in a graph. So we have to understand the working of Bellman-Ford algorithm. This used in many applications in graph theory. For example, the figure shows 5 nodes. If A is a Mumbai and B is a Pune, then the lines represent roads connecting them. The graph can find the shortest path between any two cities. Adding distance between neighbors, we can find the shortest distance. Example A to E. We have two routes A, B, C, E, and distance from this route is 7 plus 4 plus 4 is 15. And second route is ACE. Distance is 5 plus 4 is 9. So shortest path is 9. Normally, distance vector routing algorithm uses hop count. RIP stands for Routing Information Protocol and it is used in autonomous system. Distance is a metric used by RIP. For that reason, RIP is used hop count to find the shortest path. Infinity is defined as 16, which means that any route in autonomous system using RIP cannot have more than 15 hops. The next node column defines the address of the router to which the packet is to be sent to reach its destination. Figure shows an autonomous system with 7 networks and 4 routers. The table of each router is also shown. Let us look at the routing table for R1. The table has 7 entries to show how to reach the network in the autonomous system. Router R1 is directly connected to networks 130.10.0.0 and 130.11.0.0, which means that there are no next hop entries for these two networks. So if you observe the R1 table, then 1 and second is not having a next hop entry and remaining are having a next hop entry. So according to that, we can find the routing table for each and every router. This is an example of updating routing table. So the RIP message from C, after RIP message from C in increment, so it is giving +1, and this is a new routing table. This is a broadly explained example how the initial routing tables in a small autonomous system. So B is directly connected to network 14 and 55. So network 14 and 55, it is having a 1 hop count and remaining next hop is a dash. Similarly, every network is showing the directly connected nodes. This figure shows the final routing table for that example. So if we want to route B to network 66. So if you observe the routing table for B, 66 is a destination address, then 2 hop count, and next is a C, because from B to network 66 we have to travel 1 hop and second hop, and the medium or the between B and network 66, the C router is there. That's why it is the next hop is a C. But if you observe that B to network 55, B to network 55, 55 is a destination address, 1 is a hop count, and next router is not there because it is directly connected to B. Similarly, we can find each and every node how it is connected to B, and routing table is prepared in similar fashion for every node. So figure shows final routing table. In next video, we will study packet format for RIP. Thanks for watching video. Happy routing!